Human Factors and Behavioral Performance. I'm Jennifer Fogarty, the Chief Scientist of the program. Next slide. This conference is intended to clarify the solicitation and improve the quality and responsiveness of the proposals in a relatively timely and efficient manner. So this is a good opportunity for us to talk through the material today with you and then have a questions and answer session at the end, and we'll talk more about that as we go along through the chart. It does offer an opportunity for NASA to provide potential proposers with information or emphasize existing information in the solicitation that you could benefit from. It also offers you the opportunity to pose questions and receive answers and clarifications. This conference is open to anyone who has the information to join. The entire Q&A and discussion between NASA and attendees will be accessible to all attendees. The presentation and Q&A will be posted on the NSPIRE's website. The link is present on the charts for you. NASA personnel may engage in some sidebar discussions if we have to determine the best way to answer your question. So we will take time off the mic to do that before we give you an answer. That will be both live at the time we respond and be tracked on the website for other people to refer to. If we don't have someone here to answer the question or we need to gather more information, we'll defer it and we will come back and answer it via the website through the Q&A section. So for those of you who may not be familiar with our program, it is an applied research program. We perform the necessary research to understand and reduce spaceflight human health risks and also health performance. We enable development of human spaceflight medical and human performance standards. We also develop and validate technologies that serve to characterize and reduce medical risks associated with human spaceflight. Next chart is an agency-level graphic talking about the various phases of exploration. Currently, we're in phase 0, which relies both on the terrestrial use of analogs as well as the International Space Station and low Earth orbit. We are moving toward a phase 1 cislunar space opportunity in the near future. Please read our solicitation carefully because we are still working well within low Earth orbit and in ground-based analogs. But our efforts are moving toward a cislunar gateway capability with a phase toward complete a deep space transport, which will give an opportunity to do validation and verification for the Mars mission, with ultimately phases 3 and 4 of missions to the Mars system and to the surface of Mars. A little bit more about the Human Research Program, our components. We break down our work into areas called elements. There's exploration medical capability, which is dedicated to understand the medical care for missions, development and design of the medical architecture for the future. There's human factors and behavioral performance, focuses on the interfaces between the humans and the vehicles and habitats, and also the individual and interpersonal behaviors that may change before, during, and after mission. There's human health countermeasures that focuses on changes in physiology with respect to the stressors that humans will encounter. We have ISS medical projects. That's our implementing arm. They provide the infrastructure for flight and analog experiments. And our space radiation element focuses on radiation exposure and biological effects. I'd like to mention we are very interested in the cross-discipline and inter-element interactions on all the risks, given that the humans are going to experience the stressors of spaceflight in their totality rather than one at a time. We also, the Human Research Program also funds a cooperative agreement called the Translational Research Institute for Space Health, otherwise known as TRISH. They run their own independent research announcements, and really by design they're meant to be very disruptive with the solutions they bring to the table. They work both a very low TRL, which is technology readiness level, or CRL, countermeasure readiness level, or a very high readiness level, and that infers either very fundamental kind of new and novel techniques, methodologies, or findings, or very mature, we're almost ready to field and do operational studies with. HRP has a variety of venues where we conduct our work. I already mentioned the International Space Station, which is in low Earth orbit. You're going to have microgravity, assigned crews, a small amount of galactic cosmic radiation exposure, but considered very minor compared to the transit to Mars or actually landing on Mars. The current astronaut corps are considered radiation workers, and their radiation exposure is tracked accordingly. The NASA Space Radiation Lab is in Brookhaven, at the Brookhaven National Lab in Long Island. It is a facility where we are able to do animal, cell, and tissue studies with various radiation exposures. Right now we are doing a GCR simulation capability that has a complex set of ions that are delivered in smaller and more refined packets over several days or weeks to do a better job at doing dose exposure. NBHAB is a facility in Cologne, Germany. It is capable of doing head-down bed rest, isolation, and it also has facilities such as short-arm radius centrifuge and in-house imaging capabilities such as a 3 Tesla MRI. The Human Exploration Research Analog is a facility located here at Johnson Space Center for isolation studies of 30 to 45 days with crews of 4. We currently do missions there on a regular basis, and that is also an analog that we control here at the facility. So with our focus of being an applied program, we discuss risk mitigation. You'll see as a structure, if you go to the HRP website, how we articulate what our relevant risks are and our priorities for them. Currently, we have 34 risks and concerns relevant to exploration within HRP. The focus on risks, they're focused on risks that could have substantial negative effect on an exploration mission. So you'll see the coding within our path to risk reduction is a stoplight. So red, yellow, green, with red meaning exactly what it implies, stop. The mission may not be able to go forward if we don't have the answers or the risk mitigation necessary. Yellow is a caution. We're in a position that we probably characterize and know something about the risk and have some level of risk mitigation, but we think we can improve that posture. And green means we're in a position that we are in acceptable risk. The elements in the program have identified gaps both in knowledge and mitigation capability. Where we emphasize with these topics, we need to identify the research products required to fill the gaps, and that's what we're articulating in the topics as you read them. And we also articulate the research products that need to be generated to meet those gaps. Okay. The following page is, again, the overall integrated path to risk reduction. You see a composition of all of the 34 risks and concerns articulated out on the left column. Each one of those risks has an evidence report that synthesizes the information that's been pulled together thus far from all sources, meaning terrestrial, space flight, that weighs into our thinking on the likelihood by consequence, which is the second column, the L by C. Those rankings give you an idea of where this sits in terms of priority as well as the color. Across the top, you'll see a number of years. That is just looking at the time horizon. The next level down are important exploration milestones that are coming forward from the agency. The EMs are exploration missions 1, 2, and 3, and so on, as you see. We also have key events, such as the currently planned end access of ISS, which is at the end of 2024. These charts are updated as the agency makes decisions about whether those dates will move and in which direction and how those facilities will be available to the HRP program. So right now we still are going to be showing the 2024 until we have new data to move that. As you move down the list of risks, again, we put our highest priority red risks first. We look at the milestones that need to be achieved and in what order they need to be achieved in order to approach a risk reduction strategy that meets the needs of the design reference mission. Again, there's a lot more information available on this chart at the HRP website for any one of these risks. And of course, for this appendix, it would be particularly relevant to look at the topic areas and the risks that coincide. As a spaceflight research program, we do have certain constraints and some goals. We do have constraints on schedule, access to crew, and our needs for risk mitigation are different from those that may be occurring, say, at NIH or NSF, and that you might see reflected in their solicitations. So the International Space Station analogs are a limited resource, so we prioritize these topics that you're seeing today in Appendix D, but as the proposals come in, due to budget constraints and the facility constraints usually limits the number that we can select and implement. When you talk about using the astronauts as subjects, both the number and demographics of astronauts vary, so we do a lot of work to understand how to get the biggest value out of small N research, given the high degree of human variability. The agency exploration architecture will influence and does influence our priorities. So oftentimes, depending on which design reference mission has been put forward as a challenge to us, we may have to reprioritize to be responsive to the agency needs. And overall, our focus is on human system risk reduction. We're here to mature and applied research. We have to balance that against the need for mechanistic and fundamental research. So oftentimes we have to make choices between the two, and we may have to offer up not knowing every detail of how something occurs, but still be willing to test a mitigation strategy and see how much risk mitigation we can get. Given we mentioned the constraints on the astronaut core, various cohorts, even in analogs, we put a lot of value on the statistical considerations and planning for any of the proposals that come in. We do require a statistical section to be submitted with the proposal. So we're looking for a robust statistical design of the experiment to make efficient and effective use of the limited resources as mentioned. The small N studies will not always be capable of achieving the ideal sample size or statistical power, or if you're in the field such as ISS, you may not be able to control all the extraneous variables with margin of error. So it's critical that the data analysis considers this, and it's still a plan. It's still a sound plan. We do a multi-step process. So step ones are a letter of intent at this point. Step 2 proposals, the full proposal when they do, must include a dedicated section describing the statistical approach or justification for not needing one. It's pretty rare to meet the justification for not needing a statistical approach, I will say. The proposed sampling procedure, experimental design, and data analysis methodology will be evaluated by a statistician on the peer review panel. So a little more detail on the actual solicitation process. As I mentioned, it is a 2-step process. The step 1 proposal submitted to NASA should include a synopsis of the intended research. We have a page limit of just 1 page, which is new for this cycle, and we're trying to be much more efficient. For this appendix, Appendix D, the step 1 proposals are due on the 29th of April by 5 p.m. Eastern in the Inspire system. We're asking for all step 1 proposals to follow the specifications listed in the solicitation. So only applicants who submit a step 1 will be invited to do a step 2. The step 2 proposal window opens on the 30th of April. And as I said, it's a letter of intent. So if you have a step 1, you will go to a step 2. If you do not submit a step 1, we do not accept a step 2. In case that wasn't clear. So the step 2 proposals are due on the 9th of July, 5 p.m. Eastern, again on the Inspire system. The page limit in the Central Scientific Technical Description is a 10-page limit that is also new for this cycle, which is a reduced number of pages. The step 2 proposals will be reviewed for merit and programmatic relevance. So the merit review will be conducted by a panel of scientific and technical subject matter experts. And NASA will evaluate the programmatic balance, feasibility, and cost of the proposal. The final award decisions will be announced in December of 2019. So the solicitation topics for Appendix D of this HERO are effects of spaceflight durations up to 1 year in low Earth orbit on cardiovascular structure and function in astronauts. The second topic is individual and team problem-solving skills training for exploration missions. All of the details of both these topics can be found in the solicitation material, and we are available for the question and answer session with our element scientists to provide any insights or clarification you might need. Okay, so the first question, as one of the identified key requirements, your document stipulates that for step 2 proposals, if you recently submitted to Trish and were not accepted, then we must address prior review or comments. You recently applied for NIAC grant but were not selected. So we are not, NIAC and us, I think, have very different objectives, would be receiving very different proposals, so we don't expect you to be responsive to the NIAC peer review via the proposals you would submit to us. Can you provide more information on cardiovascular effects? I think that's the question. That's the topic. So in spaceflight, we have evidence reports that document changes in cardiovascular, including the cardiac structure and function itself. We're going to be doing one-year missions, and we would like proposers to help us understand how you would evaluate changes in that structure and function over that duration of spaceflight. Step 1, cost information is not expected. This is a technical letter of intent, essentially. We'd like to understand what content you're going to bring forward. In regards to topic 1, are you looking for research proposals to use analog data from astronauts or alternative methods? Welcome. For example, Heimlich unloading. Now, this is a flight study with the use of astronauts. So we're looking for a proposal that would use humans in space flight, actually. For projects using only astronaut plasma samples for analysis of various relevant processes related to CVD, function, oxidative stress, inflation, be appropriate. From the concept of how it might impact function, the question is both structure and function. Will computational cardiovascular modeling be relevant to this announcement? I think if that were incorporated into, if you were gathering the data and then modeling the data to predict outcomes, that might be a reasonable approach. Of course. We have Dr. Peter North going to add a comment.
So I would say that, what we're really looking for is data sampling during a one-year mission, 6 months and 2 months. So just modeling what would happen without that data would probably not be sufficient. So we would need you to gather, because we don't have data beyond the 6 months for cardiovascular variables. But the computation modeling on top of that will be fine.
Right, in addition to.
Yeah, in addition to.
Okay. Next question, parabolic zero-G flight analog facilities available. That is not part of this solicitation offering. What types of diagnostic tests are going to be on these space flights? In the solicitation material, we have appendices that outline the types of standard measures that are done on crew members. That's also done under a research protocol, so they volunteer, but we get a high degree of volunteerism. There are also by the medical requirements, which is a data sharing, just the standard measures. So I think if you would propose what type of clinical measurements or diagnostic tests you would need, it may be covered by something we already do, and then it's called data sharing. If your proposal is chosen and you need that for your science, then it's implemented as part of the proposal that's selected. Sorry, correction, okay. Okay, so topic A is ISS flight. Topic B is analog only. So A is flight, B is analog. So the individual and team problem-solving skills those proposals should be designed to be in an analog, a terrestrial analog. For effective space flight durations of up to 1 year, that is a flight study. Cardio biomarker changes monitoring is of interest or not. In the context, again, of structure and function, biomarkers are of interest to identify and be able to understand what they're telling us, interpret. For blood draw, can plasma as well as bucky coat cells be prepared aboard the ISS? So our position is that we have a lot of capability on ISS, and we have learned how to do a lot of sampling and sample preservation. If you have a study you'd like to propose, it's good to propose the science as you would need it done, and then we figure out the technical accomplishment of it. If we can't, we work with you to understand how best we can serve your purpose. So that kind of detail we could answer through ISS&P specifically, but I would say we actually have come a long way to be able to meet most of the needs. So that could be answered in more detail later to Dr. Kabrowski. We get encouragement, discouragement to sort of letters after phase 1? No. Ultimately, if we have to review phase 1 and give feedback, if feedback went to everyone, so we decided that step 1, as long as you bring the LOI in, you're eligible for step 2 if you so choose. Will we be able to have access to PowerPoint presentation from today? Yes, this PowerPoint presentation will be posted. Oh, no, we already got that. Okay. Anti-choice. So that we're clear, our proposed countermeasure, etc., would need to be flown to ISS for use by astronauts, or maybe use the facilities at Cologne as an analog for studies with the facilities in question. So for this appendices, topic A is ISS flight only. Topic B is a terrestrial analog only. You need to read, depending on which topic you're proposing against. I don't believe either one of them are facilities in Cologne at this point. Sure.
You're absolutely right. The first topic is for flight, but not entirely only, because we have, at the end of the solicitation, there's actually a paragraph indicating that we will consider isolation study cardiovascular that's in association with problem. As a control.
That has to be partnered with the proposed flight study component. Okay. The investigators have access to the existing cardiovascular data in the astronaut. You have to request the data that you need. There's a data request system. We have the lifetime surveillance of astronaut health involved in reviewing these proposals. If a data request is part of a proposal, if selected, you will undergo a feasibility for that data request as well, and they'll work with you to understand how much of the data that you're requesting actually exists and is able to be delivered. What cardio-diagnostic tests are currently being carried out? So on the research side, standard measures, again, is available in the appendices. So on anonymous, any comment on why topic 1 extends up to 6 years, while topic 2 only to 3 years? When you have a flight study, in order to get the adequate N number, usually it takes multiple years because we accrue the N number so slowly. So we cover at least 6 years in terms of the funding profile. While the study will be active, it's just slow at data gathering. In topic 2, because you have better control over the number of N that are run at a time in an isolation analog, you can accrue the N number more quickly. The expectation is to have that study completed in 3 years. Asking for a rough idea of what reasonable limits exist on crew member blood plasma volume availability. The maximum amount on a monthly basis for crew members in flight is 150 mils. The last 30 days of the mission is only 100 mils. That is for all purposes. So if multiple studies are asking for blood, they're integrated by that ISS medical projects workforce who implements flight studies. And they work across to be able to leverage those blood samples. So that's part of the negotiation. If you're chosen and you require blood, you go into the pool of studies that are all in that case, and for the studies that someone may volunteer for, and they maximize the amount of science they can get given that limit. And the proposal for topic A involves plasma markers related to only vascular, not directly cardiac function and structure as related to atherosclerosis risk. Yes. How many awards were made for topic 1 and topic 2? Right now, the budget allows for 1 proposal to be selected in each topic. Could you elaborate on the exception of permitting an analog study for topic A? So for topic A, what Dr. North was explaining was that they do allow for a control group in an isolation analog to be used in comparison to the flight data that's gathered for the same experiment. So it would be a partnered, in your proposal you'd be partnering a flight arm with a ground-based control arm. Clearly the crew is getting microgravity and a small amount of GCR and slightly different stressors, whereas the ground control would be getting the isolation under whatever circumstances the implementation is occurring, so you have slightly more control over the variables in the isolation. So that's, I think, what, Peter, if you want to elaborate.
That was excellently formulated. Thank you. Yeah, we are not currently doing very much inside. Of course, we have the MID, right? That's to be data here, and we have standard pre and post flight in particular. I think we are doing ultrasound also inside on the. No, we're not doing that. So that's pre and post flight. But however, suggest anything you need to do, and we will do our utmost to implement it. And there are actually a lot of facilities on board. We have ultrasound capabilities that can be used. And I would also point to some of our IP equipment. There's a rebuilding equipment that's pretty efficient, which I know of because I used it before I came to NASA. Very good. You can use for cardiac output measurements as well as for all kind of respiratory variables. But there are other equipment, but you state your needs as exactly as you would like it done, and we'll try and implement the best solution.
Yeah, just a slight clarification for those of you who heard Dr. North say the Med-B. So medical requirements are carried out on the crew both pre and in post-flight. They are available for data sharing, but I think what Peter was emphasizing, and is correct, some detail on those requirements are publicly available if you were to search for them. The important part is your design and the data you need to accomplish your scientific aims. If that data is gathered via a medical requirement, we could share that data rather than repeating that data take. But if you need it and say the clinical side is not doing it, it will be implemented on the science side. So you're not dependent on it already occurring, nor are we asking you to figure out ahead of time how to leverage off of that, state your needs for evaluation as your proposal requires. And then the follow was, can we use AI methods for data analysis and modeling? Yes, we would not limit, for analysis and modeling, we would not limit the capabilities you would bring to bear on it. Artificial intelligence. So if they had data sets from large populations, could that interpret the results? So, yeah, that would not be an interesting proposal to read.
Thank you. I've been thinking a little bit. So actually, to summarize what the capabilities are right now on the ISS and what previous researchers have used by equipment is the following: ultrasound for all kinds of imaging, in particular vessel size, cross-sectional areas, as well as flow. And this has been in particular focused on the upper body because of our same problem, but it could be on other parts of the body as well. It be something called internal jugular venous pressures by outside compression and ultrasound imaging at the same time, which is something that's also been of interest. It's a cardiovascular but also sense related. You can use ultrasound for measurement of cardiac output. You can also use the breathing method by which is called in the portable pulmonary function system, and you can measure absolute values of cardiac output versus relative changes using ultrasound. There's a capability for 24-hour monitoring of blood pressure. For calculation of total systemic vascular resistance related to flow measurements as well. And I don't know, Steve, but you know this better, whether we can do flow-mediated dilatation in the eye, whether that has been done. So that has also been done, flow-mediated dilatation. In addition to that, as Dr. Fogarty correctly indicated, you can state your requirements and we'll try to implement it. And as my deputy, Dr. Barr, has emphasized, we have pre- and post capabilities that are much broader, but this will also depend on you can bring your own equipment for doing that, and orthostatic field testing in our standard measures, right? And other measures. Yes? Could you hear me? Thanks.
Yeah, so I'll be available. Yeah.
We'll post the link to all these questions online, and in addition, we'll have a YouTube recording posted as well.
So the next question is, if we propose to utilize HERA and our proposal were selected, would that help allow for a higher priority to gain that access? So how we look at HERA campaigns, and a campaign is comprised of kind of a year-long series of 4 missions. We look at the types of proposals and types of science we want to achieve in that campaign. So we try to match the science with the overall goals of the campaign.
Next one was for experiments that involve plasma analysis in which plasma samples may require antioxidant addition prior to freezing. Can that be readily incorporated into the procedure during definition process for yes? So that would be exactly the type of thing that our implementers would work with you on to get the right procedure. That could be done before freezing. Seems very probable.
Right.
Very possible. Yeah. If you are selected, our team will work with you on those details. The question was what the NSRL DCR mixed field experiments are currently encouraged allowed. So we actually don't have a space radiation topic or a topic that would be using NSRL in this appendix. So I think just look for future topics. We have three opportunities a year. We try to stick with the same schedule, so it'll be July, November, and March. There we made it into April due to delays with the furlough. A slight slip. So that's the best we can offer, is that a future topic may have a NASA Space Radiation Lab DCR mixed field experiment. This Appendix D does not have one of those topics.
Hi, Anonymous 2. This is Tom Williams. I'm the element scientist for Human Factor Stable Performance. The question is, are the expected deliverables in Topic 2 tied to an existing training protocol, or can they be generic training and countermeasure prototypes? So they're not tied to an existing training protocol per se, but what's important for us in this particular topic is that the training be focused on the type of problems that a crew would likely face. And that's why when you look in the solicitation, you see the reference to the contextual inquiry that's been done with former astronauts and with flight directors for the types of problems that have they confronted. So that's what's important to us, is problem solving that helps us solve a problem that will be legitimately faced or likely faced by crew. So that's what's most important in terms of bringing forward a training protocol for the problem solving.
The next question, are morning fasted blood collections possible in addition to those performed at other times? We've done that many times. It's essentially a standard for us. So assuming it fits into the mission and it fits into all the other things that are going on, yes, that can be done. The next one, how many samples per mission are being collected? Propose how many you need, and then we'll work with you from there. It varies greatly depending on the experiment. So if you want to use standard measures as a basis, most of those samples are collected 3 times: early mission, mid-mission, and late mission. But that does not restrict you to only 3 collections. You would need to propose what you think you need for your science.
So, and the question is asking about in terms of medical requirements, the standard amount of blood that flight surgeons collect for general health monitoring. That is not currently a part of how we base our science. So there are documents publicly available that will state what medical operations currently does on orbit from a medical requirement standpoint. Blood collection is not one of them. So right now the standard measures incorporate from a science side how much blood we collect regularly and why. And again, we can leverage off of that depending on what your requirements are. So it's kind of necessary but not sufficient to meet your needs. So then we have to evaluate how much collection you need when you need it and meet the needs of the science that's chosen.
All right. For David Traore, are there any documents that can allow us to develop a proper statistical section for this call? We don't have a document per se, but we do have we encourage you to work with your statistician at your institution, but we also have JSC biostatisticians who could potentially consult with you as well, and we can post that information online. And will a link to the previously mentioned YouTube recording be available at the same link? Yes, we will provide that link all on the Inspire's website.
Anonymous 2, for topic 2, would a proposal focused on the individual skills alone rather than the team skills alone be totally out of scope? Yes. We're looking for primarily team problem-solving skills, but also within that context, since an individual will have to do some aspect of an individual effort as part of the team, we want to see how the individual effort integrates into the team problem-solving effort.
you're right, Ben. Thank you for that clarification regarding the sample size specification guidelines. And certainly it would be acceptable to reference the relevant gap numbers by the references in the HRR Team 1, Team 2, etc. And as far as the Step 2 full proposal is concerned, the shorthand for the gaps would also be acceptable. You don't have to write out the whole gap.
I think it's your call, Terry, to make, because whatever you write down gets publicly put out there because it's part of this set. If you have something off topic and you want to email me, I think my address, oh, there you go. Here's the, okay, I did give a couple talks recently, and part of the discussion was about pharmacogenomics, being able to type people's cytochrome P450 to know who or which drugs, how you metabolize them so that you go in. Okay. So I don't have a specific test I was talking about, but the concept of applying that, where in spaceflight, if you could pre-know that, you could really make sure that the crew is getting medicine that will work for them. Because a lot of times you can't pre-test medications in terms of, yes, you can test it for adverse reaction, but the person doesn't have the problem at the time that the drug is effective for, so you don't understand effectiveness. So the example with space motion sickness, you can test the motion sickness meds to make sure the person's not adversely affected ground testing them before, but you actually can't test them to know how they deal with their motion sickness, because we're not going to go intentionally cause the motion sickness to pre-test it. So that was my discussion about the use of pharmacogenomics with respect to cytochrome P450. So I think there are various tests out there, and there's a lot of information via the FDA about the use of pharmacogenomics and the various forms of cytochrome P450 that make sense with classes of drugs that are more likely to be used in spaceflight now or in the future, either for treatment of a disorder or even prevention. So that's kind of where that discussion string came from my presentation.
Regarding Dr. Kowarowski's flight experiment resource worksheet question, that document is posted on the 2018 Hero Overview Documents website on Inspires. It may not necessarily be associated with the solicitation, but if you go one step up, it'll be on that Overview Document website.
We're glad you found that the session helpful. We've been running these on my voice for a while. So we are glad you see value in it. It is important that we record everything and also provide written history so other people can access it. We've just got a few minutes left. We do keep it in an hour. We're going to close it out in about 2 minutes. Thank you, Ben. That's a link directly to the HERA solicitation. One more from Anonymous for topic 2.
So from Anonymous for topic 2, any advice or clarification on how to scope or effectively develop one proposal that covers such a huge research area by staying focused on the fact that we're looking for problem-solving techniques and training standards and guidelines related to the types of problems that a crew is likely to encounter. So problem solving can go in many different directions, but distill it down, select some areas that you think are the most relevant based on the listing that's shown, and then develop training guidelines, training approaches appropriate for a team to problem solve on those type of problems that will allow us to generalize to other types of problems. So use a good strategy that will allow us to generalize. That's what's most important. For Anonymous 2, is there a list of typical problems for topic 2? If you look on Appendix D, page 10, where we've used the contextual inquiry with astronauts and with flight directors for the type of typical problems they would encounter, and if you have more specific questions, there's contact information, and we can provide you more specific typical problems, but we'll post it on the board for everyone else to know as well.
So the last question is, can a U.S. entity subcontract with a Canadian or other foreign academic entity? The Canadian academic entity must have a letter of support from their government, whether that is from, for example, the Canadian Space Agency or a governmental, it has to be a Canadian, they need to be supported by the government that sponsors them. So for Canada, it needs to be a Canadian governmental entity. Yes, supported in terms of funding. Yeah. U.S. dollars cannot be directed to a Canadian researcher or any foreign researcher for that matter.
All right, well, we've hit the golden hour, and we see that most of the folks are wrapping up. We'd like to thank you for participating in this event. We hope it was useful for everyone, and just a reminder that this will be available to go back and use for reference. We hope you all have a great weekend. Thank you very much.